Okay, now let's talk about section 2.3. Lines. Okay, line in the XY plane. When you have a general line, it looks like this, possibly, or it looks like this. So sometimes the line is more steep, sometimes the line is more horizontal. So there is a one quantity which measures the steepness of the lines. So what is a quantity? It's like this. For example, from this point, P, you move to Q. So P has coordinate x1, y1. P has coordinate x1, y1. Q has coordinate x2, y2. Then when you move from P to Q, x changes. How do you measure x changes? This is x changes. This horizontal is x change. X change is called the run. Horizontal is called the run. And then from P to Q, also y value changes. Y value from this height to this height is called the rise. And the ratio rise over run is a numerical measure for the steepness. If this raise over run is very big, you see here, big raise, small run, it is more steep. If this raise over run is very small, it's more horizontal. So rise, not raise, sorry. Rise over run. Rise over run measures the steepness of the line. Okay, so we're going to give the name of this ratio, rise over run. So let P x1, y1 and Q x2, y2 be two distinct points. Okay, so two different points. And if x1 is not equal to x2, so what does it mean? It means you really have a run. If x1 is equal to x2, then there's no run, just totally rise. Then we cannot define the slope. Why? Because a run cannot be 0, it's a denominator. Okay, if x is not equal to x2, x1 is not equal to x2, the slope, this is definition, the slope m of the non-vertical line L, so this line is called L, containing P and Q is defined by slope is y2 minus y1 over x2 minus x1. y2 minus y1 over x2 minus x1. It's actually exactly the rise over run. Here, of course, we require the denominator is not 0. x1 is not equal to x2. When x1 is equal to x2, actually you determine a vertical line. Here we need a non-vertical line, so x1 is not equal to x2. Okay, for the vertical line, there's no slope. Okay, so that's the definition. What is a slope? And right after the definition in the textbook, there is some explanation. Okay, what is explanation? Remember that the slope is y2 minus y1, x2 minus x1. It's the rise over run. And y2 minus y1, from this, you can consider it is the difference or the change in the y direction. So it's a change in y. Rise is a change in y. The x2 minus x1 is a change in x. Okay? Change in y over change in x is a slope. Change in y over change in x is a slope. And sometimes we use a symbol delta y to represent the change in y. Delta y is y2 minus y1. What is the change? Of course, delta x denotes the change in x. Delta of x is x2 minus x1. Okay, so the slope is a delta y over delta x, and the delta y over delta x, the change of y over the change of x is also called the average change, average rate of change. Of y with respect to x. Of y with respect to x. Okay, so that's another name. Slope. What is a slope? Slope is the average rate of change. Slope is a change in y over change in x. Slope is a rise over run. Okay, and there's a technical issue. When we have 2 points, P and Q, we don't know which one is x1, y1, which one is x2, y2. So possibly we call P x1, y1, Q, we call Q x1, y1, P x2, y2. So it doesn't matter because this is a randomly labeled. But we will compute the same slope. Check here. If we use y2 minus y1, x2 minus x1, or we use y1 minus y2, x1 minus x2, these two things are equal. Why? It's because here, if we factor out negative sign, then y1, y2, let me write this way. Okay, so first I switch those two numbers. So it's a negative y2 plus y1, negative x2 plus x1. Okay, so that's the first step. I switch the order. Switch order, I get the minus and plus. And then I factor out the negative sign. And I can cancel them. So that gave you the connection. So when you compute the slope, really it doesn't matter which point has coordinate x1, y1, which point has coordinate x2, y2. You can consider either point, and any one of them is the first one, and the other one is the second one. But the important thing is that if you use a pair, you have to put them in the same position. If x is in the second position, y should also be in the second position. You cannot mix them. You have to. This is one point. The coordinate of one point. This is coordinate of the second point. Another point. Okay. So you cannot mix. If you mix them, you get it wrong. Okay. So that's a technical issue. It doesn't matter how do you label the P and the Q. You can label them in whatever way you want and use whatever order. y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. They are equal. Okay, so example. Now assume we have point 1, 2, and another point 5, negative 3. 1, 2, and 5, negative 3. Let's try to compute slope. Slope, difference of y, 2 minus negative 3. You see here, I just select the first y coordinate minus second y coordinate. Remember here it's always subtraction. First y coordinate minus second y coordinate, and first x coordinate minus second x coordinate. Y coordinate minus y coordinate, x coordinate minus x coordinate. So 2 minus negative 3 is 2 plus 3 is 5. 1 minus 5 is negative 4. So the slope is negative 5 over 4. Okay. You can use a different way. You see here, if I use negative 3 minus 2, and then you have to use 5 minus 1. Negative 3 minus 2 is negative 5. 5 minus 1 is 4. The same. It doesn't matter how you do subtraction, but you cannot mix. Okay, let's see another example. Let's see, we have several lines. L1, the line 1 passes through P2, 3, and the Q1, negative 1, negative 2, P, L1. L2 passes through P2, 3, this 2, 3 is fixed, and Q2 is a 3, negative 1. L3 passes through P2, 3, and Q3, 5, 3. L4 passes through 2, 3, and Q4, 2, 5. 2, 5. So we have four lines. Let's try to label them. So we have maximum 5, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, 2, 3. You have 1, 2, 3, 4. 2, 1, 2, 3. 2, 3. This is P. This is P. And negative 1, negative 2. Okay. Negative 1, negative 2 go down. So this is negative 1, negative 2. This is Q1. And 3, negative 1. 3, negative 1 is here. It's a Q2. 5, 3. 5, 3. This is Q3. 2, 5. 2, 5. It's Q4. Q1, Q2, Q3, Q4, and then we have P. This is P. Okay, now let's check. Let's compute the slope for each line. So M1, the slope for L1. Y minus Y. X minus X. 3 plus 2, 2 plus 1. It's a 5 over 3. So first slope is 5 over 3. Where is it? Here. This is L1. Okay, and M2. M2 here. Y minus Y. X minus X. So numerator is 4, and 3 minus negative 1 is 3 plus 1, 4. 2 minus 3 is negative 1, so it's negative 4. Negative 4. So here, okay. This is L2. The slope is negative 4. M3. M3 is Y minus Y. 3 minus 3. X minus X. 2 minus 5. 3 minus 3 is 0. 2 minus 5, negative 3. 0 over 3 is 0. So slope is 0. This is L3. Okay, and the last one. Last one you see here, you cannot format 3 minus 5 and 2 minus 2. 2 minus 2 is 0. Denominator cannot be 0, undefined. We know there's only one case functions, the slope is undefined. You have a vertical line. So what is vertical line? See this one. See, it's exactly a vertical line. It's vertical. So this is L4. Okay, so that's a computation. And from this computation, let's check. This is L1. L1 has slope 5/3. If slope is positive, this line, the line slants upward from left to right. Okay, so this way. It might be this, but the general direction is always from left to right. It slants upward. And second, if slope is negative, this way. Slope is negative, then the slant downward. The line slants downward. From left to right. This way, you go down. If it's positive, you go up from left to right. And 3, slope is 0. The line is horizontal. This line, the slope is 0. The line is horizontal. Slope is undefined. The slope is undefined, then the line is vertical. The line is vertical. So that's all four cases. Slants upward, slants downward, horizontal, and vertical. Okay, so that's a 4 general case. Okay. Okay. And also, if we carefully use calculator and the graph equipment to sketch it, you will see that if for those two, because they are both slant, upward, so M1, M2 are both positive. And now we want to compare M1, M2. For line L1, it's more steep than line L2. So if you have more steep line, the slope bigger. So here we can see that M1 is greater than M2. M1 is greater than M2 because line L1 is more steep than line L2. Okay, and this is for the positive case. For the negative case, remember both of them are negative. When this line is more steep, the absolute value will be bigger, but for the negative function, it becomes smaller. Okay, so this is a comparison of negative number. This way, it has bigger ups value, but it's smaller, and this one has a smaller ups value, it's bigger. It's in the negative world. Remember that negative 2 is less than negative 1. Okay, so that's what it means. So there's some careful computer graphed lines to describe it. Okay. Now let's see. Example. If we are given a point and the slope, how do we draw the line determined by the point with the slope? Draw a graph of the line that contains the point 3, 2 and has a slope of, there's two cases, A 3/4 and case B, second one, negative 4/5. Okay, so we're going to solve two cases. The idea is the following. First, you label this point 3, 2, 3, 2. This is a 3, 2. You have this point. The line must pass through the point. Then we are going to use the condition of the slope. How do we use the condition of the slope? This is a, remember, this is a rise over run. Rise over run. What is a run? Remember the positive. Positive run means you have to go right 4 units. 1, okay, it's bad. 1, 2, 3, 4, okay? This is a run. Up 3 units. Rise is 3 units. 1, 2, 3 is possibly here. This is 3, this is 4. So that rise over run is the 3/4. So this is going to be your, okay, see, first you go right 4 units, and then from this new point you go up 3 units. It's positive, both positive. So you get your second point. And then you use your ruler to determine this line, to draw the line. Yeah. So this is going to be your line. Okay, understand? So when you have a positive slope with a ratio, then you first to move to the right 4 units, move to the denominator 4, and then go up 3 units, numerator 3. And that's the second point. You have the original point 3, 2 is given, and then you have your second point. You sketch the line through those 2 points. That's uniquely determined. Okay, so this is a case for the slope equal to 3/4. Positive, you move to the right. Okay, still the same thing. One, 2, 3. 1, 2. So 3, 2. And now for the second problem, you get a negative 4/5. Negative 4/5, you're supposed to move to the negative direction. Here is positive, move to the positive direction. Negative slope, you move to the left. Positive, move to the right. Okay, run is 5, so you get 1, 2, 3, 4, 5. So you move to this point. This unit, this is a 3. This is negative 2. The distance is 5. The distance is 5. This is 5. And so this is 5. And after you get 5, remember this negative sign is already used. We determined to move to the left because of the negative sign. It's already used. You don't need this negative sign. You read the numerator 4. 1, 2, 3, 4. Okay, 4 units. This is your second point. Important second point. This is 4 unit. And then you sketch it based on the ruler. Okay, so this is the line through the given point with a given slope, rational slope. Okay, so negative sign tells us we're going to move to the left. Positive slope means when you do the rise, you move to the right. This is left. And for the quantity, you ignore the sign. You just use 5 and 4. Just use 5 and 4. Okay? So this is a problem. How to draw the graph of the line containing a specific point with a specific slope. Okay. Graph the equation or graph the line x equal to 3. Well, let's try it. X equal to 3. Let's graph it. You already know x is 3. You just pick up y. 1, x is 3, y is 1, x is 3, y is 2, x 3, y is 4, x 3, y is 1 half, x 3 is y is negative 1, negative 2. So when you get sufficiently many sample points, you will see that x equal to 3, the graph is a vertical line. A vertical line with the x-intercept 3. It intersects the x-axis at 3. Okay, so all the vertical lines have more or less the same equation, x equal to something. The only difference is about the x-intercept. So you see here, this is x equal to 3, it's a vertical line. This is x equal to 2, it's a vertical line. This is x equal to 1, it's a vertical line. The y-axis is also vertical. It's x equal to 0. So every point on this line has x coordinate 0. And if you put them in the middle, it will be the vertical line x equal to 1 1/2. Yeah. Okay, so that's our vertical line. In the textbook, they list it as a theorem. A vertical line is given by x equal to a, where a is the x-intercept. So all the vertical lines will have such equation. Now let's make this stuff general. Okay, so how did we do this? How did we do that? So we have a point. It's P. It's x let's say x1, y1. We have a slope m given. We want to determine the line through the given point with a given slope. For example, let's see this. This line is a line satisfying the containing the given point with a given slope. Now, what is the equation of this line? The equation of the line is written by the following. Assume you have a random point. The random point, let's call it Q, on the line. The random point has coordinate x and y. So we just want to see the property of x and y. It's a point, a random point on this line. Then you can set up or you can compute the run and the rise. So the run the run is x minus x1. The rise is y minus y1. So from run rise definition, the slope is y minus y1 over x minus x1. The slope through those 2 points. But we know that slope has to be this m. So this ratio is equal to m. So for arbitrary point, this condition should be satisfied because they equal to the same slope. Okay, then I move this denominator to the right side. We will get y minus y1 is m times x minus x1. This is the multiplication. And then this is called the point slope form. Point slope form of an equation of a line. So whenever you have a given point with a given slope, you can always write down the equation directly by the point slope form. Okay, so for example, an equation of the line with slope 4 and containing the point 1 and 2 can be written by what? By the point slope formula. So y is the coordinate of the general point. Y is never, it's a variable. Y is never determined. Y minus y1. Y1 is the y coordinate of the given point. Y minus y1 is equal to the slope times x minus x1, x times x1. So this is a point slope form. Point slope form. Okay? And from the point slope form, we can get another special case. So before we state the special case, let's recall. At the beginning, we mentioned a horizontal line has slope 0. Vertical line has no slope. Horizontal line has slope 0. So when you get 0 slope, the right side becomes 0. 0 times whatever thing is 0. 0 times x minus 1 is still 0. Even it has x, but the product is 0. So you basically will only have y part. Okay? A horizontal line has slope 0. Then let's say the next example. Find an equation of the horizontal line containing the point 3 and 2. Okay, so here you see the problem does not even mention the slope of horizontal line. It is hidden by this horizontal word. Horizontal means slope is 0. Okay, so y minus y is equal to 0 times x minus x coordinate. Y minus y coordinate, x minus x coordinate, and times 0. Times 0 is 0. So you get y equal to 2. Y equal to 2. So this gave us the general case. A horizontal line has an equation given by y equal to b, where b is the y intercept. Horizontal line, y equal to b. Vertical line, x equal to a. Okay, so that's two special positions. So this line only depends on the height. It's like your roof. The roof, you say your roof is 2 meters tall. Your roof is 1.9 meters tall, or your roof is 3 meters tall, whatever. It only depends on the roof, the height. So this V is a height. Vertical means like a tree. Tree is a vertical. It depends on its point on the ground. So x equal to a, x equal to 2, x equal to 3, x equal to negative 1. So you have two special type of line: horizontal, vertical. Vertical, no slope. Horizontal, 0 slope. Okay, and let's do one more example, and we'll stop for this. Let's stop this video and continue next time. And sometimes they don't give you slope under the point. They give you 2 points. Find an equation of the line containing the points 2, 3 and negative 4, 5. Why it's enough? Because we know that every 2 point will uniquely determine a line. So definitely it is sufficient. The question is, how do we write the equation? The thing is, if we know the slope, we can use the point slope form. So how do we find the slope? You have 2 points. Of course you can find the slope. So the first we find the slope. Slope, y minus y over x minus x. Y minus y, 3 minus 5. X minus x, 2 minus negative 4. 3 minus 5, negative 2. 2 minus negative 4, positive 6. So it's negative 1/3. So the slope is negative 1/3. And then we can apply the point slope form. The question is, you have 2 points. Which point do you choose? It's up to you. You can select either of them. You will get the same thing. Okay? So it doesn't matter which point you choose. You will always have the same thing. Well, the textbooks choose 2, 3. Let's choose a negative 4, 5 and see what happens. Okay? So we choose negative 4, 5. So the point slope form is y minus y is equal to slope x minus x. Slope x minus x. So this is the right answer. This is the right answer. Why it is right? Remember that, check here. If we choose this one, it is going to be y minus y is equal to slope x minus x. They're different. They look different. Well, let's see if they are same or different. Okay, let's compute. Let's simplify it basically. So the first one, y minus 5. So do negative 1/3. X minus negative 4 is x plus 4. And then you do multiplication. It's a negative 1/3 x minus 4/3. So negative 1/3 times x, negative 1/3 times 4. And then you move 5 to the right side. So y is equal to negative 1/3 times x and negative 4/3 plus 5. This is minus. You move it to the plus. And it's negative 1/3 x. So 5 is 15/3. So it's negative 4/3 plus 15/3 is plus 11/3. Okay, so we have this formula. This comes from the first choice. And in the textbook, they select this one. Let's see if it's the same or not. Negative 1/3 times x. Negative 1/3 times negative 2 plus 2/3. And then we move this 3 to the right side. So y is negative 1/3 of x plus 2/3 and plus 3. Minus 3. Move here is plus 3. 3 is 9/3. So 2 plus 9 is 11. So it's negative 1/3 of x plus 11/3. See? Identical. So it really does not matter which point you choose in the point slope form after you figure out the slope. Okay? So in this section, the section is long. We will have other topics. In this section, up to current moment, we first study the slope. Slope is a rise over run. And let's review it. It's long section. Okay, so in order to clearly describe the steepness of the line, we study the rise over run. We call it the slope. It only works for the non-vertical line because the run cannot be 0. Run is in the denominator. Run cannot be 0. So rise over run, slope, with this kind of argument can be understood as the average rate of the change. Keep this word in your mind. You may see it in the exam or the final exam. Average rate of the change is the slope. Okay, so you can go back to go to the beginning of the video and check it again. And then we explain that in the definition of the slope, it doesn't matter who is the first or who is the second point. You will always have the same quantity. And then we do some computation. And from this example, we learn that positive slope means the lines like this. Negative slope means lines like this. Horizontal line slope is 0. Vertical line slope does not exist. Okay? And then we get a detailed comparison about the slopes. If it's more steep, slope is more bigger for the positive. If it's more steep, the slope is more smaller. It's a negative case. Okay, and then we know how to sketch the line by a given point and the given slope. You have a point, label the point. You use rise run to determine the second point and use a ruler to connect them. Okay? And in this example, we have the positive slope and the negative slope. Positive slope, you do all these things on the right side. Negative slope, you do it on the left side. And then we get the vertical line. Vertical line has a form always like x equal to a. And then we study the point slope form. This is one of the most important formula in the geometry. Point slope form. Y minus y1 is equal to m times x minus x1. And you have examples. And from point slope form, we get the equation for the horizontal line. Horizontal line always has the form y equal to b. And then we studied the process for the equation of the line through two given points, not without the slope, just two given points. The first step, you must compute the slope based on the formula. And second, you can choose either of the point and apply the point slope form. And this part is just convince us it doesn't matter which point you choose, you will have the equivalent solution. But up to here, it's enough. Up to here, the question is solved. The rest part is just a verification, confirmation. Okay, so this is a long section. We will continue next time about the rest of the section 1.6. Okay, we stop here. Thank you.